Hello, my name is William Ibbs, and I'd like to welcome you to this first module in a series of presentations on the subject of construction labor productivity. I have found that the subject of labor productivity is one of the most important subjects in the construction industry, and through my research at the University of California at Berkeley, where I'm a professor, and through my consulting practice at the Ibbs Consulting Group, I've worked with a number of different companies over the years and government agencies to study this subject. I'll be taking you through a series of topics associated with productivity and productivity loss here in these 5 modules that I'm presenting to you. I will say at the beginning that I'm an engineer, and many of the points that I'll be touching on here involve legal concepts and contractual matters. My perspective of that from a project management point of view, but it's important that on complex legal matters that you seek qualified legal advice and legal counsel. Some of the topics that we have covered in my consulting practice are listed here on this slide. We've spent a lot of work with companies and agencies on the subject of productivity and schedule matters, as I have already mentioned. But we also have capability of dealing with cost matters, cost accounting, standard of care, and other associated matters. In this first module, we'll set the foundation points in place for you to understand the subject of productivity and what affects productivity and how loss of productivity can be measured. This brief first module will cover, as I say, the subject of productivity and a list of the various factors that can affect productivity, and then we'll talk about what is loss of productivity and outline the direction we're going to go in the subsequent modules of this program to help you understand the different techniques that are available for quantifying loss of productivity. So why are we talking about construction labor productivity? We're talking about construction labor productivity because it's a very important factor that influences the success of a project, the timely completion of the project, the value that an owner receives for that project, and the profitability that a contractor earns on that project. We'll talk today predominantly from the point of view of labor productivity, but it's also important to understand that subcontractors have productivity, and construction equipment also has a measure of productivity as well. So let's start with the definition of productivity. What is productivity? Productivity is a measure of output, work that has been accomplished, divided by the effort expended to achieve that work. So for example, we might spend 1 hour of crew time, 1 hour of a person's time, to produce a cubic meter of concrete, a particular type of concrete. So as I show here in this particular slide, 1 cubic meter, of concrete production per hour would be a measure of productivity. We'll also talk in this series about productivity indices or productivity ratios. And an index or a ratio is a measure of actual productivity divided by planned productivity. So for example, if I had actually been able to install 1 cubic meter of concrete in the course of an hour of a person's time, if that had been my actual, and my plan had been to install 2 cubic meters of that same type of concrete in the course of an hour, my productivity ratio or my productivity index would be 0.5. So you'll oftentimes hear people talk about productivity, and you'll hear them also talk about productivity ratios. I should also mention that you'll sometimes hear people talk about production. Production is just the volume of work that's accomplished. It's not the volume of work that's accomplished in a period of time, but the overall volume of work. So if I pour a cubic yard of concrete, that's a measure of productivity, a measure of production. On the other hand, if I pour a cubic meter of concrete in 1 hour of time, that's a measure of productivity. Now, for the most part in this series, I will talk about productivity as being a measure of output divided by input, which is what I've listed as convention number 1 here in this slide. But on occasion, you will hear people use the inverse. They'll refer to the number of labor hours expended per unit of work, unit of output. One of the key points to remember when you're dealing with productivity is to make sure you understand the terminology and the definitions that are underlying your work. Why is productivity important? Productivity is important because we're usually talking about labor productivity, and on the typical construction project, labor is not only one of the most important, one of the largest cost components of the project, it's also usually the most variable or the most unpredictable component of a cost of a construction project. So here, as I show in this particular slide, we've got the typical cost components of a project. We've got labor, material, indirect costs, maybe like construction equipment, overhead, and of course profit. And in this particular example that I've constructed, we've built a project that is a $4 million project, and very typically the labor costs on a project will be somewhere in the range of 30 to 40%. So I'm showing in this particular example that the labor portion of this project is 40% of the total cost. Let's take the hypothetical example and assume that instead of actually being able to perform as planned, we have some problems that affect the actual labor productivity on the project, such that the labor costs of the project go up by 5%. The labor productivity may have gone down by 5% or some amount that correspondingly has driven the labor costs up of the project. Well, a slight shift in the productivity of a project can increase the labor costs, and with the increase of the labor costs, we can lose all our productivity, as shown in this particular little example. So labor productivity is really important to construction projects for 2 reasons. One, the labor portion of the project is usually one of the predominant, if not the predominant, cost component of a project. And secondly, the productivity of the labor is the most difficult to foresee or predict with accuracy. We can predict the costs of material with more accuracy because if we have a complete design, we can measure the quantities of materials that need to be purchased and installed before we bid the job. Okay? But the labor is highly dependent upon actual project conditions, and we don't know with certainty what those project conditions will actually be until we actually start to build the job. Now, what types of things affect labor productivity? I just mentioned that planning a project, it hinges upon being able to predict labor productivity with a degree of accuracy. It's very important to do that. Okay? But there are so many things that can affect the performance of a crew or a laborer, and thus affect the laborer's productivity. This slide is just a short list of some of the various factors that can affect labor productivity on a construction project. It's by no means comprehensive, but as many of you viewers will recognize, the presence and the absenteeism and the turnover of workers can be important. The weather conditions on a project can be very important. The availability of skilled or less skilled workers can affect productivity. And of course, very importantly, design changes or other types of changes in the work execution can have a profound effect on productivity in terms of affecting the workflow of the work, in terms of affecting the crowding and the congestion and the trade stacking on the project, and the overall coordination. Again, this is just a short list of some of the factors that can affect labor productivity on a project. And when I go in to look at what has happened on a disrupted project, I am looking for these types of variables and what was planned for versus what actually happened. Now, there are many different models and quantitative approaches for planning productivity as well as analyzing productivity. I present this slide to you just to give you an idea of the types of models that are out there. And by necessity, a model, of course, is an abstraction or a hypothetical situation of what, a hypothetical simplification of what actually happened on a project. But we can use these type of models. Analysts and planners can use these type of models to try and predict and try and understand what actually will happen on a project or what has happened on a particular project in terms of labor productivity. By no means should any of these models be used without forethought and without careful consideration of the underlying facts actually occurring on the project. But these models are helpful in helping us to understand and communicate about potential problems, mitigating those potential problems, analyzing problems that have already occurred, and assigning responsibility for problems that have occurred. This all leads up to the subject of loss of productivity, a very important topic. Okay. What do we mean when we talk about loss of productivity? What we're typically talking about is the difference, the mathematical difference between what level of productivity was planned on a project or could have been realized on a project versus what level of productivity was actually realized, was actually encountered and realized on a project. So it's important to, first of all, understand whether the plan was realistic. Was it prepared with full consideration of all the likely conditions that the contractor was going to encounter on the project? Does it take account of all the considerations and constraints represented on the drawings and on the specifications and the other contract documents, as well as by the project site itself and the circumstances, the environmental circumstances around the project, environmental, commercial, bidding circumstances around the project itself. So having a good understanding of what was a reasonable baseline for a project is a first start in understanding loss of productivity. Once we have an understanding of what was reasonable and reliable as a baseline on a project, then we compare that to what was actually encountered on the project. And we look at that mathematical difference and we say, we had planned to spend 100 hours doing this work. We spent 120 doing this work. The difference between the two is 20 hours. Then we have to determine what is the source or the sources for that 20 hours of difference. And once we identify the sources, we can then start to assign responsibility. Are all 20 hours the responsibility of the contractor because he didn't have a good estimate or he didn't manage the project well? Or are they the responsibility of the owner because of design changes? Or are they the responsibility of a subcontractor, what have you? But it all starts with this idea of what was a reliable and reasonable baseline for productivity on this project and comparing that then to what actually happened on the project. Ideally, you can measure that in real time. A contractor can measure that in real time and understand what's going on at the time of the project. But there are many instances where it's not possible, it's not practical to measure that in real time. And the measurement has to take place retrospectively after the project has concluded. And we'll talk a little bit more about that later in this series. There are models, there are approaches that are widely accepted in the industry for measuring such loss of productivity in such circumstances. I mentioned a minute ago that measuring productivity and measuring loss of productivity is important and it is difficult. Why is it difficult? It's oftentimes difficult because the record keeping and the documentation that a contractor assembles during the course of the project may not give us the specific information that we need in order to really measure productivity loss and measure responsibility for that productivity loss. As a case in point, many times contractors will set up a cost account system that measures the hours expended for forming, reinforcing, and placing concrete in a slab, in a concrete slab. And they'll use one cost account to cover all three of those work activities: forming, reinforcing, and placing the concrete. Well, if each of those activities is done by a different party. Let's say the general contractor does the forming, a subcontractor does the reinforcing steel, and another subcontractor does the actual concrete placement. Then it can be hard retrospectively to identify who's responsible for any productivity overruns, productivity deficiencies, if you've only got that one cost account. So setting up a cost accounting system and using that cost accounting system is paramount for measuring productivity and understanding productivity. But a lot of times it's not practical to do that, or it's not convenient to do that, or the contractor isn't set up to do that. So that's an important challenge that I see in many instances like this. Okay. It's also very important to identify causation. Identify what caused productivity loss with specific detail, and who's responsible for that causal effect. We'll talk about causation over and over again in this series of videos, but that's oh so important, is to understand what really caused the productivity and be able to communicate that, explain that causation in persuasive detail. So many cases, so many arguments, so many claims fail. Loss of productivity claims fail because of the failure to establish causation in a persuasive sort of way. All the different methodologies, all the different quantum methodologies that we talk about in this presentation are useless if you can't establish causation. So first and foremost, you have to establish causation, then you establish liability, and then you go into the quantum aspects. So we'll talk a lot about causation later, and we'll also spend a lot of time talking about the methodologies, the quantification techniques that are available for measuring loss of productivity. In this presentation, I will be relying upon a number of published resources that I have found useful and reliable for my teaching and my consulting work. And each of these modules has a list of the key resources that I think are appropriate for the particular topic that we're addressing in the module. Okay. Of course, you're always welcome to contact me at my address as listed here on this slide if you have questions or if you need help about productivity issues, or for that matter, any other construction-related topics such as cost accounting or scheduling or standard of care. We have a wide experience of doing such, working with clients on a variety of different type of projects on these different topics, and I'd welcome your inquiries. Thank you very much.